Welcome to Brain Vision.
So this problem starts by writing the balanced equation for the combustion of propane to form liquid water and gaseous water. And so we'll start with gaseous water, so C3H8 gas plus 5 O2 gas forms 4 H2O gas plus 3 CO2 gas. And then we'll write the same thing again, but with the only change being liquid water. So then moving into problem B, we want to find the delta H of reaction of each of these. And so since it gives the delta H of combustion for this first reaction, being the HHV, as negative 2219 kilojoules per mole, we know that's our answer. And as far as the delta H reaction for the one with liquid water, we just take our 2219 kilojoules per mole and add the heat of vaporization of water times the number of moles of water. And this is explained in the problem, and that gives us an answer of negative 2043 kilojoules per mole. Now moving on to letter C. It asks when propane is burned on a propane fueled grill, what is the heat released? Is it the HHV or the LHV? And it is the HHV because we are creating H2O gas when we do that. And then it asks us to determine the amount of heat released from 1 kilogram of propane. And so we start out with our 2219 kilojoules per mole. We divide by the molar mass of propane, 44.1 grams per mole. And then we just convert grams to kilograms. And then we get our answer as 50,317 kilojoules of energy are released from 1 kilogram of propane. And now I'll go to a new page for letter D. And this asks us what is the average increase in the absolute value based on the table of these heats of combustion when we add another carbon to the chain. And so we just take the higher value and subtract the lower value from the table, and we just do this for all the values all the way down the table. And then we can divide our final answer by 7 since we will have 7 of these, and that will give us the average. So all of these values are from the table, and I'm just going down and subtracting by the previous one, taking the absolute value of both. And doing this, and then we divide the whole thing by 7. And doing this gives us an average increase of 654.3 kilojoules per mole. And that is our final answer for letter D.